Today we're going to talk about weeds as indicated by my title. The title for my speech today is Comparison of Inflorescence, Seed Development, and Fecundity in 5 common Waterhemp cohorts. This is the outline for my speech. First, I will give you a brief introduction of the background of my little research project. And then I will put forward the hypothesis of this research, and then we'll move to the experimental design and methods, and then analysis and results, and finally we'll come to the conclusion. Okay, so what is common waterhemp? Common waterhemp is increasingly problematic weeds of agronomy production system throughout the United States, Midwestern United States. It keeps on creating problems to the farmers. It is found that common waterhemp populations of 200 plants per square acre decrease soybean yield by 43%. And when common waterhemp density reach 8 plants per meter of row, the yield of soybean will reduce to 56%. Whoa. One of the characters that make common waterhemp hard to control is that they have a discontinuous emergence pattern, which make them able to germinate throughout all the growing season that most other summer annual weeds that can't. We may know that emergence of timing of germination is a critical change that affecting other life history changes because the different environmental that the plants experience. Well, what could this life history change be? Could it be growth rate? Well, yeah, it's reasonable to think so because plants from later cohorts will suffer from will compete with plants in the early cohorts, and besides, they will suffer from changes in the environment as the growing season progresses. All these factors will result in lower growth rates. How about seed production? There are many factors that affecting seed production, like plant size, pollen and resources availability. All these factors are different among cohorts. So, could these will cohorts affected by these effects so that they differ in their seed production? And how about seed germination response? This is always an exciting part for me because for us human beings, we inherit many qualities from our parents, no matter good or bad. And plants does so too. And this is interesting, isn't it? It is found that the conditions for those mother plants experience will affect their offspring on their germinability, dormancy, and thus the fate of the next generation. This has been testified in many species. But there's little literature on this phenomenon on common waterhemp. So we'll see. And this is our hypothesis. We hypothesize that common waterhemp cohorts have different life history chains, and resulting reproductive characteristics will reflect these differences. To testify our hypothesis, we come out with many the following more specific questions like: do rainfall events and temperature influence common waterhemp emergence? Do later cohorts have earlier flowering days, faster seed development than early cohorts? In other words, do later cohorts have faster vegetative growth as well as reproductive growth? And some other questions like, what is the seed contribution to the soil seed bank for each cohort. And those cohorts different in seed dormancy and germination due to the different environmental conditions they experience. To figure out these questions, we took a series of experiments. Our research was set up at Curtis Farm of Ames last summer, and our first site is 4 5 meters by 5 meters cohorts for cohort 1 to cohort 2. And due to the decrease of plant density of the last cohorts, we enlarged the last plots to 12.5 meters by 2.5 meters. And we set up our cohorts when they are clusters of seedlings, and the seedling emergence was defined as full expansion of 2 cotyledons. The plants that in each cohort was marked and counted. All the seedlings that emerged after that certain day we set up, the cohort was removed. To answer our first question, we record the emergence day of each cohort and measure the weather conditions throughout our study. This is the equipment that we use to measure the rainfall, the air and soil temperature. To answer our second questions, this is the second experiment. Here we want to compare the vegetative growth as well as reproductive growth among different cohorts. We define the vegetative growth as the time interval between emergence and the flowering, and we define the reproductive growth as the time interval between flowering to when they get viable seeds. And we'll see how it happens. This is the method we use to do it. For flowering date, we just record the dates when there are recognizable inflorescence appeared. And for the seed maturation time, we do a germination test to those seeds collected from different time of seed maturation stage, like the day 1, day 3, day 5 until day 30. Here I have to clarify that the day 1 is the day that the plants generate enough branches so that I can get enough seeds for the germination test, but not the day that they get flower. I will add the day they get flower to this seed development day. And this is the germination condition. We use alternating temperature, and the experiment lasts for 14 days. And to handle the last question, to compare the seed production, 5 female plants were randomly chosen from each cohort. After 1 month after they flowered, seeds were harvested, and then 0.1 gram seeds were weighted, counted, and this will be converted into total seed production per square meters. And we also measure the female plant height. And this is the last question we are interested. Do these seeds we get from the cohorts, how will they behave in the next generation? And this is, since this experiment is still in progress, we'll not cover it today.
Thank you for watching the Agronomist Podcast. YouTube limits video lengths to 10 minutes. You can watch this seminar in its entirety at the Department of Agronomy website, www.agron.iastate.edu.